Alright, so this is sprint 4. First to address, show line has been completed. I'll show that off during the final, when we run the program. Moving on, the collidables now all have a default sphere. Uh, we can get this through a private function, only available through the attorney. Um, that's just so that the user doesn't have to mess with it too much. Going into the actual collidable, we initialize the pointer here, and then when they select the model, if they select for B-sphere, we set it to have the same pointer, but we update the collision data both times since this is usually going to be called once per frame, and I didn't want to throw in an if statement, though it might be worth it to just get this double computation out of the way. And then we have one last if statement in the destructor just to make sure that we're not going to double delete a sphere and a volume at the same time. Fairly straightforward. Moving on to the collidable groups. Each group has a method now, update group AABB, and then a get function for what their group AABB is. And it simply goes through. This is the of all of the vertexes. We have a lot of checking, but once it's all done, we have a group AABB with a new set data function. We have two new functions in the AABB to help this process go smoothly, and then we just go ahead and visualize it for later. This is only done once per frame because we go to the collision manager, process collisions, which is called once per frame. Under this function, we call update group AABB once, and then we do the test commands for everything else. This basically guarantees that the test commands that we're not calling it multiple times a frame, we're only calling it once on every group, every frame. So that's all of the collision stuff out of the way. Just to show, we have compute data with a B-sphere and then set data given two vertices, and all of the associated information gets calculated correctly. Moving on to the personal projects, we have our plane mower basically finished. It travels forward, turns around, travels back, and just continues in this oval-shaped pattern. We haven't implemented the dropping the bombs yet because the bombs themselves are not finished, but it's almost there. We just have to finish up the explosion part of it, having it spawn a large B-sphere, which I'll have to figure out how to do. But once the bomb is done, the plane will also be done, and from there, that we'll have our two enemies that we're going to be using for our game. Finally, we have billboarding completely done. This is all of the code that calculates what we need in order to have the sprite, quote-unquote, always face the camera. It's pretty messy. I'm going to have to figure out a way to make this a lot smoother. I feel like this is also, we have a lot of, I feel like this is going to take a lot of time, especially since we're going to be calling a billboard function on potentially hundreds of sprites every single frame. So I'm not exactly sure how I'm going to make this smoother, but if you have any advice, feel free to tell me. Moving into the actual game demonstration, as we can see, so we have 3 enemies out right now, and you can see their group AABB right there. You can see that they're also firing bullets with their own AABB, which is a little harder to see. And you'll notice also that when the bullets get close inside of this AABB, I draw the default B-sphere, and since none of them are hitting, we're not actually drawing the you can see the default AABB pop up every now and then too, which is the final test. Moving on, this is the billboarding test that I was using. So as you can see, no matter where the camera moves, the sprite is always going to be facing the camera. And then we'll just go down just to show off all of the angles. And then finally, zooming overhead is our plane. I set it to a low height. It's probably going to be higher, but it's a little jittery, but for now, it does get the job done. Okay, the jittering problem gets worse the longer the game goes on. But for now, it's basically how I want it to act in the final game. Before I forget, however, I also wanted to show off the commands just to prove that we're doing our tiered testing. So here, we're getting the two group AABBs, and we're testing them against each other. And then we get one of the default B spheres, and we test it against the AABB. Then we get the second B sphere right here, and then we test the two B spheres against each other. And if those collide, only then do we get the collision volumes for each, test it, and then process the callbacks if it's a collision. So that's the between the pairs, but for the self, we are only testing each B-sphere against each other B-sphere. So we grab the two B-spheres, test them against each other, and if they do intersect, then we grab the collision volumes and test those. So that is the sprint. Finally, I just want to talk about my project a little more. You mentioned briefly that the particle system could have different. You said that it was emitting out in a sphere by default. I've already thought of wanting to change that, make it like a spout perhaps, or like a ring. So that's what max and min emit angle are going to do. Potentially, it could also be buried under burst type, which is some enum I'm going to make. Or alternatively, burst type could just be, I could have preset particle effects. So I could have like a water spout type effect where all of these values are pre-filled in for the user to use. Something like that. Burst type is just going to affect the... I guess I'll just have to figure out exactly what I want it to be. But max and min emit angle are the goals for that. I would love to draw, but I don't have a whiteboard function here. So that's the update, I guess, on my project. Billboarding was quite difficult to do, but it finally worked out. So I will see you next sprint.